Alright guys, let's go ahead and start Unit 2. Alright, by the end of today, hopefully you'll be able to give the definition of each of the following words below. What is a function? What is domain input or independent variable? Those are all synonyms. Range output or dependent variable. Those are also all synonyms. And then we should be able to look at a function and determine whether that data represents a function or not. You should also be able to tell when you're looking at a function which of the two variables, because every function is going to have at least two variables probably involved with it. You should be able to identify which one is the input and which one is the output. Okay? So that's our objective for the day. So let's go ahead and start off with what is a function. A function is a relationship between two variables. Okay, so let's say that Mrs. X and Mr. Y decided to form a relationship. The input variable, also known as the independent variable. The output variable is one that's known as the dependent variable. Okay, so one of these variables depends on the other one. Now, for a function, each input variable is related to only one output. So let's talk about what that means for a second here. So in this little box up here at the top, we have two variables. We have time and distance. Okay, time is related to distance, and one of these variables is going to be an input and the other one's going to be an output. Now, almost always when it comes to story problems that involve time is almost always the input variable. And what that means is it's the independent variable, and what that means is time operates on its own without anything else affecting it, usually. Okay? So, I mean, it doesn't matter how far you drive. Time is time. It doesn't change, right? But time, if you're driving, will affect how far you went, right? So the longer you spend driving, the more distance you cover. So it's not exactly true, but it's a fair comparison to say that the input is kind of like the cause of the output in a lot of ways. So in this case, time is the input and distance is the output. Okay. Now, each input variable is related to only one output. Actually, I probably shouldn't have put the word variable here. I guess I could have put the word value. Each input value is related to only one output value. So, for instance, when the input is 0, it has only one output that goes with it, 2. And when the input is 5, the output is 3. And when the input is 10, the output is 3 also. Each one of these inputs is connected to only one output. Okay? Now, that's not true in the reverse, though. So, for instance, if I were to say to you guys this little statement down here, an output variable can be related to more than one input, though, right? So, for instance, 2 is related to 0, but 3 is related to 5. And we can kind of just ignore this line right here real quick. Because this 3, since the 3 is repeated in the output column there, that 3 is technically being related to two different inputs. So it's okay for the output to connect to two different inputs, but it's not okay for the input to connect to two different outputs. All right? So that's kind of how that works. So, in other words, you shouldn't have any repeats in your input column. If you have any repeated numbers here, then that means it's not a function, because in a function, every input should only be connected to one output. So if you have the same input repeated twice, that means it's probably being connected to two different outputs. So that would not be a function. But we don't really care about the other column. The other column can have repeats if it wants to. Now let's talk about some ways to represent functions here. So this is what I call the symbolic way of representing a function. And I would encourage you guys on your notes to add the following notes. The one in the parentheses is the input. All right. And the answer that you get out is the P in this case. So this would be the output. Now the F is just a symbol that represents the concept that, okay, these two variables, P and T, are indeed connected to each other by a function. So that's what that means. And it doesn't always have to be the letter F. Usually it is, because F stands for function, right? But sometimes if you're talking about more than one function, you can use different letters. So long as you see a letter with parentheses next to it and another letter, that's probably going to represent a function notation. Okay. Now here's something that's kind of odd here. Is we could say that the output is P, right? But since P is equal to F of T, then technically we can also say that F of T is the output. So both of those are outputs. But the input is just a T. Okay? So the output, you could say the output is P, or you could say the output is F of T, since they're the same. But the input has to be just T all by itself. Okay, so that's one way to represent a function, is symbolically. You can also represent a function. A function can be represented as an equation. Okay, so I'm going to erase this to make some space, but you guys want to make sure you're adding these notes as we go. So equations are cool because unlike this that just kind of tells you, okay, we have two variables, T and P, and they're related to each other by a function, this one actually tells you how they're related. Okay, so in this case, this one is telling you that P is related to T in the following way. P is 2/5 of T. Okay, so that tells you what the relationship is. So equations are a better way to represent a function because they actually tell you what the relationship is. Now you guys will notice that I wrote it twice, and that's because here I used P, but down here I used F of T. It doesn't matter because, as you remember from part 1, P and F of T are the same thing. So if we're using the top one, then the one that is on this side with all the other numbers and stuff, that's going to be the input variable. And the one that's by itself is going to be the output. Same thing over down here with this one. The T is the input. You can also tell that the T is the input from over here, right? Because the number or letter that's in parentheses is the input. But the whole thing, F of T, is also considered to be an output. Okay, so T is the input, F of T is the output. All right, and what that means is that P depends on T, or F of T depends on T. All right, let's look at it again. So now here's the verbal one. That's kind of what I just said, actually. Verbally, and this is important because in this chapter, a lot of your homework is going to be coming straight out of your textbook, which I know you guys didn't pick that up, but I'm just cutting and pasting pictures from your textbook into the document for your homework. And so your textbook will use these sentences here every once in a while, and you need to know what that means. So if somebody says to you verbally, or if you read in a book, P is a function of T, okay, the one that comes first is the output. The one that comes last is your input. Same thing in this representation, because there's two different ways you can say it verbally. You could say P is a function of T, or you could say P depends on T. So in this case, output and input. So whenever somebody speaks in English, the phrase P is a function of T or P depends on T, whatever variable they say first is the output, and the second part of the sentence there is the input. All right? It's important to know which one is the input and the output, and you'll see why, so just hang in there with me for now. Now here's a table. So now, whenever they represent to you a function as a table, what they're really doing is they're telling you specific values. So for t and p, they're telling us that when t is 0, p is 0. When t is 5, p is 8. And when t is 20, p is 8. Now, for the table one, if whichever column has no repeats, then that variable can be your input. But if a column has repeats, I misspelled repeats, oh well, then that's your output. So in this case, since there's an 8 repeated in the p column there, then that means that p cannot be your input. It has to be an output, because we said before that every input has to connect with only one output. If we drew the arrows the other way, then we would have the number 8 connecting to 2 different outputs, so that wouldn't be a function anymore. Okay, so let's go ahead and take a look at one more way to represent functions, and that's as a graph. Okay, now a graph is another way to represent a function, and that's whenever basically you take the numbers that you get in your table here, and you plot the points and connect the dots, right? So the input is the one that's on the x-axis. Or to be more general, I guess we'll just say horizontal axis. So the input goes on the horizontal axis. The output goes on the vertical axis. Okay, so I've shown you 5 different ways a function can be represented symbolically with an equation, verbally, a table, or a graph. And in each one of those ways that a function is represented, you should be able to identify what the 2 variables are, and which one is the input, and which one is the output. Okay, so let's go ahead and do example 1 here. Example 1 says, determine which variable is the input and which variable is the output from the information provided. All right, so in this problem for number 1, this is the symbolic representation. And when you have the symbolic representation, the letter that's in the parentheses, in this case y, is the input variable. The letter that is all by itself is the output. Output. Well, it says outpat, but oh well. Or you could also say f of y. It could be L or f of y is the output. Okay, let's go ahead and take a look at the next one here. Number 2, weight depends on exercise. So I've got 2 variables here, weight and exercise. Now this is the verbal representation. Whenever we have a verbal representation of a function, the one that comes first is the output. So my output is weight. And therefore the other variable, which is exercise, would be my input. Number 3, the number of miles driven is a function of time. That's another verbal representation. It's just the other one. So let's go ahead and take a look at that. So the number of miles driven is one of my variables, and time is the other variable. The one that comes first is the output. So my output would be number of miles driven, and my input would be time. And like I said, anytime you're doing a word problem, time is always the input. It's pretty rare for time not to be the input. All right, let's go ahead and take a look at number 4. This is an equation representation of a function. So when you have an equation representation of a function, the variable that's all by itself, the y, is the output. The other variable that has all the math connected to it, that is the input. Let's go ahead and take a look at number 5. Label the axis of a graph in which t is a function of q. Now, it says t is a function of q. So this is a tricky question because I'm asking you actually to do two different problems. First of all, I want you to make a graph, right? But I also gave you a verbal representation of a function here. So first of all, let's take a look at the verbal representation of the function. T would be the output because it comes first in the sentence. Now, some of you guys might be thinking, Mr. Bailey, you said time is always the input. I didn't say t was time in this case. It's just t. We don't know what it is. Okay? So the one that comes first in a verbal representation is the output. The one that comes second is the input. So we know that we have two variables, t and q. We know that t is the output, q is the input. Now they want us to make a graph, and we're going to label the axes. In other words, we're going to put one of the letters on the horizontal and one on the vertical. And what we learned is that when you're doing a graphical representation of a function, the input goes on the horizontal axis, and the output goes on the vertical. Okay? So that's function notation and inputs and outputs. So here's one for you guys. Go ahead and pause the video here and see if you guys can figure out what the input and output is for each one of these functions. When you unpause the video, you will see the solutions. Now for number 1, it was kind of dirty pool. I told you guys time is almost always the input, but in this case it's actually the output. How can you tell? Well, they're doing the verbal representation, right? And when you do a verbal representation, the one that comes first has to be the output. Now, usually time is the input on a word problem. And the only reason I'm telling you that is because if you're ever doing a math problem or even in science, almost always they use t as the time as an input variable. But it doesn't have to be. So the most important way you can tell is by one of the 5 representations that I gave you before. But just as a general rule of thumb, yes, time is usually the input, but not always, okay? So the answer to number 1 is that speed is the input, time is the output. Number 2, the input would be q, the output would be h or f of q. On number 3, we have a verbal representation here where it says z is a function of k, which means that z is the output and k is the input. And so I've labeled mine. And on the last one there, you guys can tell that r is the input because it's in parentheses. But you can also tell r is the input because it's the variable that's not by itself. The output is f of r. Now technically, since f of r is equal to 2r squared, you could technically say 2r squared is the output, the whole thing. But it's kind of unnecessary. You can just kind of say f of r. All right, so that is function notation, inputs and outputs. And just so you guys know, going back to our little introduction here, input is also known as independent variable, and all the possible inputs for a function all those things put together is what we call the domain. Output and dependent variable, we know what those are. The range is all the possible outputs for a function. And so we've learned that vocabulary. So let's go ahead and move on to our next objective, which is to try to determine whether a given set of data represents a function or not. So let's talk about different types of functions that there are in math first. So there are certain functions in mathematics that are...
Hey, Mr. Bailey, I'm sorry.
All right, sorry about that. I had a question from a student. Anyway, back to this. So certain functions are so useful that they get special names. So we have linear functions, quadratic functions. So I think a good thing to all of these provisions here have something good to offer. So like linear functions show you what the equation looks like. That they're the kinds that are like y equals mx plus b, which we did in Unit 1. And their graph looks like a straight line, which we also learned in Unit 1. Their domain and range, which I'll get to in a minute, is described here. The end behavior, we're not going to talk about that for a while, but we'll get to it sometime. Quadratics, their equations look like this. They have a square, and their graph looks like this. We're going to talk about that later in the year. I'm sure you've seen it in Algebra 1 or even Algebra 2. And so there's all kinds here. We have cubics, exponential functions, rational functions. This is a really weird one. We might talk about it later this year. A little stair-step function. So there's a whole lot here. I'll let you guys look at it. We're going to chat about most of these throughout the entire school year. Hopefully by the end of the school year, I could give you guys a graph or an equation, and you guys would be able to tell me what kind of a function that is, and you'd be able to graph it and do all kinds of things. So that's the goal. It's a nice little resource just to keep in your guys' notebook. You probably won't use it very much, but it's a nice resource at the very end of the year to flip back and go, oh yeah, I learned all that stuff, and it's a nice little summary to have. So go ahead and keep that on hand. So now let's go ahead and we'll talk about domain and range is coming up here, I think. All right. So domain is all the possible input values, as I mentioned before, and range is all the possible output values. Okay. So for instance, when it comes to like some strange functions, like suppose I gave you guys this function, the square root function. Okay, this is a equation representation of a square root function. Okay, if you were to plug in a number for x, like let's say 4, you're going to get an answer for y. And what that means is that you're allowed to plug in 4, because when you do, you get an answer, because every input should have one output. But there are some numbers you're not allowed to plug in. So like for instance, what if you had plugged in a negative 4? Well, there is no such thing as a negative, there's no such thing as the square root of a negative number. And therefore, negative 4 is not a possible input. It turns out that the domain of a square root function is anything that keeps the stuff underneath the square root positive. So as soon as you plug in numbers that make the stuff underneath the square root negative, those are numbers that are not part of the domain. Those are numbers you're not allowed to plug in for x. So when it comes to the function we talked about in our last unit, linear functions, there is no limitation. You could plug in anything you want to for x. You're always going to get one answer for y. Okay, so some functions have an infinite domain, some functions have a limited domain, and same thing with range. Sometimes they have an infinite range, sometimes they have a limited range. In other words, the y values can be limited. If you guys look at the exponential function, for instance, on the function worksheet, exponential functions generally look something like this. Okay, well, they always go to the left forever and they always go to the right forever, so there's really no value of x on the x-axis that doesn't exist. So your domain is infinite. You can plug in anything you want to for x, but notice how the graph never goes below the x-axis there. So there are no negative y values for this function, and therefore it has a limited range. The outputs are limited. So we're going to talk a lot about that, so if you're not quite understanding, that's okay. I'm just trying to give you a grasp of the understanding. But basically, domain is all the x values that you could possibly have for a function. Range is all the possible y values that you could possibly have for a function. Okay? So how can you tell if the relationship between x and y represents a function or not? Okay, we're going to look at that question in two ways today. One way we're going to look at it is from a table, and one way we're going to look at it is from a graph. So if I give you a table, the way you can tell it's a function or not is every input should have only one output. If it doesn't, then that does not describe a function. For a graph, we're going to do something called the vertical line test, which is just a visual way of doing the same thing, but we'll explain it when we get there. So here we go. Determine if each relationship below represents a function f of x equals y. Now, this is a restriction. I'm telling you that x has to be the input and y has to be the output. Okay? Because I've defined it like that up here. So, let's go ahead and take a look at our table. Is it okay for x to be an input and y to be an output for this table? Well, when it comes to tables, so long as the input has no repeats, it can be a function. So does my input row have any repeating numbers? The answer is no. There's no repeats. So therefore, the answer is yes. F of x seems to be a function of y. Okay? Let's take a look at number 2. For number 2, we have to say that x is the input because the problem up here tells us it is. And we have to say that y is the output. Okay? In this case, can this be a function, f of x equals y? And the answer is no, because my input column has repeated numbers. The rule for functions is each input has to have one output. So 7 is related to 9, but 8 is related to 2 different numbers. So that ruins it. Therefore, no, this table cannot represent a function f of x equals y. Now, if you wanted to reverse it, if you wanted to say this, if you want to make y the input and x the output, then that would be a function. But if you want x to be the input and y to be the output, no. And that's what the problem's asking. So our answer to that one's going to be no. All right. Now, for graphs, how can we tell if a graph represents a function or not? Well, we're going to do something called the vertical line test. But before I do the vertical line test with you, I want to explain how it works. So, are these pictures graphs that represent a function where f of x equals y? In other words, x is the input and y is the output. Well, let's pick an input value. Like suppose I pick 4 for my x value. Well, if on my blue line, where does x equal 4 on that curve there? Well, here's a place where x equals 4, and here's a place where x equals 4. So for the input of 4, I have an output of 2. And for the input of 4, I have an output of negative 2. So as you guys can see, for this one input here, I have 2 different outputs. And therefore, that's not a function. Now, here's how we can tell if it's a function in a much easier way without doing so much work. If you can draw a vertical line and it hits your graph more than once, the answer is no. It's not a function. The vertical line represents a specific x value. And in order for this to be a function, each x value should only have one y value. But every time it hits your graph, that's a y value that it's touching. So for this x value, for this vertical line I drew, there's 2 different y values, so this is not a function. Let's go ahead and take a look at number 4. Okay, if I draw a line right here, it hits the circle twice. So the answer is no. That's not a function either. Now, some of you guys might be thinking, well, what if you drew it like right over here and it hit the circle once? Now is it a function? The answer is no. It should never touch the circle in 2 places. So if you can find a graph where it never touches it in 2 places, then that's a function. Just because it works for one point doesn't mean that it's a function. It has to work for all points. In other words, there's no value of x that is allowed to repeat. Okay, so let's take a look at the next one. What about this one? Would this be a function? Well, let me draw a vertical line right here. It hits it once right there. Okay, so far we're good. How about here? Hits it once. It seems that no matter where I draw this line, it's only hitting it once. So therefore, for this one, we would say yes. It is a function. Okay, number 6. Now, if I draw a line here, it only hits it once, so that's good news. Now, some of you guys might be thinking, though, what if we drew a line here? Doesn't it hit it twice? And that's a really good observation. But actually, believe it or not, the answer is no. So let me explain why it's actually not touching the graph twice. you guys might notice something. I don't know if you can tell or not on your worksheet, but if you can't tell on your worksheet, then make it look up more obvious. Because on my screen here, you guys can see there's a difference between those dots, right? This is what we call an open dot, and this is what we call a closed dot. A closed dot means that that point is actually on the graph. It exists. An open dot means that that point doesn't exist. The graph never touches there. So when I draw this vertical line, it doesn't touch anything there because there is no point there. It touches here, but it doesn't touch the open dot. So even if I drew a vertical line through those two dots, it still only touches the function once because the open dot doesn't count. So that's kind of a weird thing. That's what we call a hole in the graph or something like that. But anyway, so the answer to this is yes, because no matter where you draw your vertical line, it hits it only once. And remember, this one doesn't count and neither does that one. So there you go. That's how you can tell if something is a function or not by looking at a table or at a graph. The whole idea is that each input should have only one output. In other words, each x should only have one y that goes with it. All right, so go ahead and pause the video here, and you decide what you think the answers are, and when you unpause it, you'll see the solutions. Okay, so here's our solutions. Yes, no, 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 yes. All right. Now, something you guys might have overlooked is what I circled here. This is very important that you pay attention to that little piece of information, okay? If I were to give you this instead, that would change some of your answers, okay? So what they're saying here is that, is it true that for every value of x, there is only one y that goes with it? The one up here is saying, for every value of y, there's only one x that goes with it. So those are different statements, okay? For this one, you would be looking to see if there's any repeats in the y column, and if there were, then you'd say no. For the one we're actually working on, though, we're looking to see if there's repeats in the x column, okay? And I didn't even show you how to do a graph for ones like this. And I'm not going to test you on it, but just so you guys know, in that case, instead of doing a vertical line test, you would do a horizontal line test, okay? Because then what you're going to do is you're going to pick a specific y value, like, say, 1, and draw a horizontal line, and that shows us there's only one x value that goes with it. But don't let that confuse you, because you actually don't need to worry about that. But it is important to pay attention to what they're asking, and that subtle little detail there matters in how we answer. All right. Let's go ahead and take a look at example 3 here. The table below shows the relationship between the population of foxes, which we're going to say is x, and rabbits, which we're going to say is r, over a 6-month period, where t equals 0 is January, t equals 1 is February, and so on. Okay, so let's look at our table and make sure we understand this. So T is month, so this is January, this is February, this is March, this is April, this is May, and this is June. And this column here tells us the number of rabbits, and this row tells us the number of foxes. So what this means is that in January, T equals 0, in January, there were 1,000 rabbits and 150 foxes in this habitat. Okay? So, let's go ahead and take a look at number 1. Is x a function of t? Is x a function of t? So in other words, what they're asking here, this is a verbal representation, and when you have a verbal representation, the first one that they mention would have to be the output. The second one would have to be the input. So, is it possible for t to be an input? That's really all we care about. Is it possible for t to be an input? And the answer is yes, because there's no repeats. So we would say yes, because there's no repeating t values. Let's take a look at the next one. Is r a function of t? Well, this is my output and this is my input, so really it's just the same question in a way. So that's also yes, because since t is still the input, we still don't have repeats in our t row. So yes, that can still be a function. All right, let's take a look at another one. Is x a function of r? Okay, now in this one, x is going to serve as my output, r is going to serve as my input. So can r actually be an input? Well, if there's no repeats, it can. So let's see, are there any repeats? I see a repeated value here and here, as well as here and here. So I've got some repeats going on there. And therefore, r is not allowed to be an input. If r is not allowed to be an input, that means x cannot be a function of r, so the answer is no. All right, number 4. Is r a function of x? So I reversed it. So now I'm going to make r the output, and I'm going to make x the input. So let's see, is x allowed to be an input? Are there any repeated values here? I don't see any repeats. And so for this, the answer is yes. Now, some of you guys might be wondering, like, so what's the point of all this? Why does this matter? Well, here's the thing. A function in mathematics and in science, it should be a formula that if you know the input, you should be able to predict what the output's going to be. So, for instance, in this case, is r a function of x? What that means is if I tell you the number of foxes, you should be able to tell me how many rabbits there are, and that's true. If I tell you there are 125 foxes, you should be able to tell me, oh, well, that means there's 567 rabbits. But let's say we reversed it, like we had earlier, this one. This is the output, this is the input. This time, if I were to tell you how many rabbits there are, let's say I told you there was 750 rabbits. If I tell you there's 750 rabbits, can you tell me how many foxes there are? And the answer is no, you can't. Because it's either 143 or it's 57. You don't know what the answer is because there's two different possibilities there. So that's why it matters, because in science and in mathematics, your input should be able to reliably predict what your output's going to be. If it doesn't, then it's not functional. It doesn't work. It doesn't serve its purpose. And so it's not a function. Okay? So that's why the input has to have one output for everything. And the way we can tell that is there should be no repeated numbers.
Right, so I went ahead and rewrote number 5. I had to add some information. Your guys' notes might need to have something added to it. So what I added here was let f of t equal x, find f of 2. So this means that t is my input, x is the output. And in this case, the t is the variable that's in the parentheses. So this is this value over here in parentheses, that's a t value. There's that. And I'm looking for the output of x. So that would be the x column. That's this one down here. So if I have a function f of t equals x, that means when t equals 2, x is 125, and that would be our answer there. Okay. Let's do the next one here. We have g of t equals r. So this is a new function where the input is t and the output is r. So I'm telling you the input is 2. Once again, we're here. But this time I want the r value. And so that's 567. All right, number 7 here says solve for t. It says f of t equals 150 foxes. Now, I'm using the same function here. I'm using the f function, which we've already defined up here. The f function, the t is the input, the x is the output. So this is an x value here. So I'm going to look under the x row for where it says 150. And we're looking for the t value that goes with it. Okay? So that would be 0. All right. Let's take a look at this last one here. It's numbered 5 for some reason. That's supposed to be 8, though. Solve for t once again. G of t is equal to 567 rabbits. So in this case, we're going back to the g function. So here's our g function. The input is a t, the output's an r. So in this case here, that 567 is an r value. Let me clean up my workspace a little bit here. There's actually 2 places where I've got 567 though. And therefore there are 2 possible t values that will give me that. And so if g of t equals 567, that could mean that t equals 2, or it could mean that t equals 4. Okay. So in other words, if there's 567 rabbits, that means that it could be February. It could be March or May. All right. So that is that. Let's go ahead and have you guys try a couple like that. Go ahead and pause the video here and work through 1 through 4. When you unpause it, I'll have the solutions available for you. All right, guys. So here's our solutions. T is not a function of p, because if t were a function of p, that would mean that p is the input, and an input is not allowed to have repeats, and we do have repeating numbers here. So now on number 2, the answer is yes. P is a function of t. That would mean that t is the input, and there are no repeating values here, so that's good. In this one, we're defining a function, h of t equals p. The function's name is h. The input is t. The output is p. So it's asking us to find the t value given this expression here. So the 15 is a p value, and we're looking for the t value that goes with that. So we're looking for where the number of people, p, is 15. That's here. And the t value, temperature, that goes with that is 50. So the answer is 50 degrees. Same function, h of t equals p. In this case, h of 90 is equal to what p value? So in this case, the 90, the one is in parentheses, that's a t value. So I'm looking for where 90, or where t equals 90. The p value that goes with that is 20. And so there you guys have it. And that'll end our lesson for the day. We'll see you guys in class to practice this stuff.